Hello everybody, and welcome back to the Poor Man's Chemist. In this video, we are going to be preparing potassium selenocyanate, which is the selenium analog of potassium thiocyanate. All we have to do is take potassium ferrocyanide and selenium powder, grind them up together, put them over a heat source until the whole thing goes black, extract it into water, and you've got a solution of potassium selenocyanate. It is literally that hard. Now, getting potassium selenocyanate to crystallize out of aqueous solution, that's a taller order. I finally had some success with this when I was playing around with this reaction yesterday, but you have to evaporate it down at, low heat, 70 to 80 C, until it gets down to where it's almost all gone. You're starting to see crystals form. And at that point, I would take it off and dry it the rest of the way with a desiccant or under vacuum. Something gentle. It doesn't seem to agree with being heated up directly, which is weird because we are making it using hot temperatures. Don't know what to tell you. Just when I tested the stuff that I had test dried and then redissolved in water, and what didn't give me quite, the precipitates weren't quite as bright. They just didn't, they looked a little off. So, but then again, I tried to dry it completely using just gentle heat. And yeah, now the stuff that was partially dry, I think was perfectly fine. It looked just like the stuff on Wikipedia. So yeah, evaporate it down almost all of the way till you start to see crystals, and then do the rest of the way either under vacuum using moderate temps or with a desiccant. Anywho, let's get on with this. If you've been staring at this, you can see that I'm going to start here with 4 grams of anhydrous potassium ferrocyanide. That means that we need 3.41 or 3.43 grams of selenium metal. Quote unquote metal. It isn't really metal, obviously. This is what the selenium looks like. It is gray selenium. I got this on eBay. JD Chemist does not seem to be in business anymore, which I was actually shocked and dismayed to see. But I got this from Luciteria. I know some people, have not had the best things to say about them, but I mean, it's pure stuff. The weight was right. It got to me in a couple days. I mean, I don't know. I didn't have a bad experience with them. Anyway, all I did was I took the big chunks they sent me and ground it up using a mortar and pestle. This stuff is very easy to grind up. It's not, it's not difficult to do. Anywho, we are going to take this and our 4 grams of potassium ferrocyanide here. We are going to put this into here. And we are going to grind this shit up until we have an intimate mixture. And nothing here is overly dangerous. I've got a glove on that hand because I got those stupid fucking cuts on my hand. And you really don't want to get chemicals into cuts you have on your hands. Just, common sense. Okay. You can see it turn the end of this thing slightly pink. That's to be expected. It's a lot like thiocyanate in that regard. Ooh, we didn't get all of it in there. Hey, get your bitch ass into there. Don't throw off my stoichiometric calculations, you son of a bitch. Who the fuck do you think you are? Selenium. Yeah, this stuff is going kind of red. It might already be starting to react. We don't have to heat it up very much to get this reaction to happen. Now, look at that, boy. Damn. Yeah, this should be a very easy one that just about anybody can do. Okay, let's see. Yesterday I did it on this. You can see it stained the porcelain a little bit. This is just a lid to a 100 ml crucible. One of the many that have died in battle. I wonder. Okay. Yeah, we're going to try it. There we go. Gonna smooth it out. We don't want to overheat it. We want to heat it just enough to get it to react, and then we want to take it off the heat and let the melt solidify. Okay, this should give it the maximum amount of contact with this thing. All right, let's go cook this shit. I don't want this to overheat. You see it will start turning kind of yellowish pretty quickly. Whoa, don't drop it down the hole, Mike. That would suck. And the smell of selenide does not take long to show up, man. All right, come on, baby. Don't fuck up on me, please. You did so good yesterday. Just fucking cooperate. Hey, camera. Stay in focus, you fucking piece of shit. All right. Be gentle. Gentleness is good. Come on, baby. That's it. React. It's okay. It's all right. It's 2022. This kind of thing is totally allowed now. No one will think any less of you. See, we got some selenium vapor coming off of it. Okay. There we go. Reaction complete. You see it kind of fumes a little bit. We're going to let that cool off, and then we are going to dissolve that in water. So I will come back when we're ready to do that. All right, so what I did, I didn't wait for this to cool down completely. When it was almost cool enough to be able to just wash it off directly into this evaporating dish, I did. I thought I had pressed record, but somehow it didn't record. It's very obnoxious. Anywho, all it did was sizzle and it splattered around a little bit. And I just rinsed it all down into here. The potassium selenocyanate is very soluble in water, so it's all gone into solution. This gray jizz in our solution, this is iron carbide. So we will need to now filter this out, and it's actually not quite as bad to filter as you might think. The crucible or any porcelain glassware that you use to do this reaction, it's actually not that bad. I mean, you can clean it off relatively easily. These are just a few little pieces that are stuck to it, and I didn't stress about it. We're not writing any papers here. I just want to demo this reaction and show you guys that it works. Anywho, I am going to set everything up for filtration, and I will come back when we're ready to do that, and I'll make sure to press record this time. So we're going to take our gray jizz-laden goo here, and we are going to pour that into here, and it's going to look like shit when it comes out the other end of this. That's why we got to filter it twice. We expect that. This is to remove the big particles. Okay, hey, that's actually doing a pretty good job. Shit, I'm okay. All right. I might be able to get away with doing this pretty much once. See what it looks like. Put this back into here. Nice. Now it'll probably take for fucking ever to filter, but we may not even have to bother with the second stage of the filtration. Now, it is during the filtration that I always start to notice the lovely aroma of selenide. I'm not 100% sure why it should have a selenide odor, other than to think that maybe we're generating small amounts of some kind of iron selenide, maybe, and it stinks, but it's a different kind of stink than sulfide. I don't care what anybody says, man. To my mind, selenide is more vile, okay? Imagine something that is like sulfide, but that smells even worse. And that's what selenide is. People always say that, like, telluride is the worst. No. No, it is not. Hydrogen telluride has the common decency to break down quickly because it's unstable as fuck. Hydrogen selenide lingers for days, and it always gives me a fucking headache, just like hydrogen sulfide does, except it's worse. All right, everyone. So it's the next day. We ran out of daylight yesterday. This is the solution of potassium selenocyanate. It's been filtered a couple of times. I covered it with some parafilm and left it in the refrigerator overnight. I have no idea how long the solution is stable for. I don't know. I guess we'll find out, won't we? Now, what I have here are 3 test tubes that contain different metal cations, which we can use to prove that we have indeed produced potassium selenocyanate, and it's not just leftover ferrocyanide that didn't break down, even though we all saw it all break down. So what we have here is a solution of lead acetate. This is mercurous nitrate, and this is mercuric acetate. All of these are supposed to form characteristic precipitates with potassium selenocyanate, and I've tested all of these, and indeed they do work. All right, so we're going to go ahead and do the mercurous nitrate first, since this stuff is kind of photosensitive. Atomistry says we should get an olive green precipitate. To me, it just looks like it's fucking gray. I mean, you tell me. Does that look olive green to you? It doesn't to me. I'll bring it a little closer here. Give it a little shake. There you go. Yeah, that's just kind of gray. There's nothing olive green about this. So that one, you know, doesn't really fall in line with what we would expect. Happily, the other two do. All right, the lead acetate. A nice lemon yellow precipitate, exactly as we are supposed to get. Very nice. Very pretty. See? Okay, so that one speaks towards us having it. You might say it could still be ferrocyanide. Okay, fair enough. Let's move on to the mercuric acetate, which should prove it for us. Now this stuff will form a yellow precipitate, which is soluble in excess selenocyanate solution. It forms a complex. Ferrocyanide will not. So here we go. Let's angle that one down a little bit more so I can add it dropwise a little more easily. Zoom in there a little bit so you guys can see the action a little better this time. Is everybody sick now? Good. Okay, focus, piece of shit. Excellent. Here we go. Nice yellow precipitate. And it is soluble in excess selenocyanate. Exactly as it's supposed to be. So, that proves that we have indeed made potassium selenocyanate. Now we can go one step further. Atomistry says if you add in mercuric chloride in roughly equal amounts, well, it's supposed to be exactly equal amounts. I have them roughly equal. Since the amount I used was so small for these tests, it was not practical to try to weigh it. But anywho, it should form a yellow, they say a double salt. It might very well be, for all I know. It might be a mixed coordination complex. I don't know. The formula Atomistry gives does not make a whole lot of sense. Nevertheless, what we need to take away from this is that we should get a yellow product that hopefully is a little bit different from what we had before. And color, the solution change. Yeah, see, that's different from what we had the first time. So there you go, people. Look at that. That pretty much clinches it. This proves we have created potassium selenocyanate. So to the subscriber who asked me one time, how come you never prove any of your preps? Well, I mean, if I'm pretty goddamn sure about what the hell I've created, there really isn't a need to. But in cases like this, I mean, where we had to do it, basically by, thermally decomposing this shit and, or basically making it at high temperatures. I mean, yeah. It's always a good idea, test it, prove it. I've never heard of anybody else playing with selenocyanates. Not saying nobody else has, they very well might have. But nevertheless, it is always good to make sure when you're working off of, a very small paragraph of information. Now, I do want to do one more prep with this, and this time we're going to make something that's actually useful. What we are going to do is we are going to make silver selenocyanate. Now, we got to move this party into the shed to do that because it's supposed to be silver chloride levels of sensitive to light, but silver selenocyanate can be used to make other selenocyanates by metathesis reaction with metal chlorides or bromides or iodides. Alright, so in order to make silver selenocyanate and get it to precipitate out not as some white curdy precipitate like you would get with silver chloride, I have 2.14 grams of silver nitrate dissolved in this here. Atomistry says we have to add an excess of ammonia to that. So I've got this here that I made myself by bubbling an absolute fuck ton of ammonia through this water. Oh my god. Yeah, a lot of ammonia. Holy Jesus. Okay. I don't know what excess ammonia means, so we're just going to go with that. Oh my god. Ah, fuck. Okay. Man, goddamn. Alright, now that my sinuses are cleared out, I'm going to bring this over here so you guys can actually see this. I haven't tested this one yet, so we'll all be seeing it for the first time. Okay. Will you please keep stirring? Stop doing that shit. It's very obnoxious. Okay. I didn't say go crazy. Alright, here we go. Well, Atomistry, did you lie to me? Maybe not. Now, I couldn't find anything that specifically said this stuff would dissolve in an excess of potassium selenocyanate. I don't know that it will. It said it was only sparingly soluble in dilute, or in ammonia rather, not dilute ammonia. Okay. I don't know, man. It looks pretty clumpy and silver chloride-y to me. I don't know where these fine needles are supposed to be. But I think it's on the money about the sensitivity to light, boy. Damn. Seriously, look at that. Holy shit. Okay. I don't know. Is it dissolving in excess? No. Still precipitating out, it looks like. I did the math. There should have been more than enough selenocyanate for the amount of silver in there. I did want to try to filter it to get some of it, but I guess I'm going to have to do that like at night or some shit. Holy crap. Oh, no, wait, I can't do that. I really don't want to leave silver ammonia sitting there for long periods of time. That's probably extremely inadvisable. Huh. Well, I don't know. Doesn't look too dissimilar for many other silver compounds I've made. They always seem slightly off color. See it there. A little bit more light to it. Well, maybe you can if I get you at a different angle. And yeah, it looks like we've got a very, well, I don't know. It's definitely in discrete little particles. That's nice. It'll make it easy to filter. I'm going to get it back in the foil there. Well, either way, I'll filter it off and I'll try to dry it and hopefully it won't explode. No, it's supposed to be very insoluble in water. And I'll go ahead and I'll wrap the video up here. If you enjoyed this video where we didn't really go for one, we proved we made potassium selenocyanate. We didn't make anything you could, well, I guess you could filter this and put it in a bottle. It was more of an experimental video, just trying to see if this would work and if we could get a, reasonable supply of it in order to experiment with it more, maybe make some cool complexes. And I think this pretty much clinches it, man. Yeah, we've definitely made it. So, woohoo, we're successful. Yay! And it's so easy to make that, now everybody has access to it. So, there you go. The big fat booty brother of thiosulfate. Or I'm sorry, thiocyanate. Goddamn. After a while, you start getting these names mixed up. I swear to God. Anywho, if you liked that video, give it a thumbs up. And if you didn't like it, well, I'll try to make the next video about, the actual set preparation of a single compound since you don't feel adventurous. Subscribe, comment, share the video. That really helps out the channel. Donate a few bucks if you enjoy this kind of crazy content where you're going to see weird shit that very few other people make because it kind of stinks like selenide. And until the next one, y'all, I will see you later.